Hi there. We are doing student activity sheet 8 today. Kruskal, it's called Kruskal's algorithm, and it's a continuation of what we did in student activity sheet 7. We're looking at what we call a minimal spanning tree, and we'll kind of explain that in the lesson. Um, and we're looking at a specific way to get the minimum total from a weighted graph, from a weighted graph, if we want everything connected with no cycles. And so it gives us Kruskal's algorithm is simply a step-by-step process of a way that we can always ensure that we get that. Okay, pretty short lesson, so stick with it. And I'm going to ask you to do a little practice on it afterwards. Okay, um, here it comes. All right, we're looking at student activity sheet 8, Kruskal's algorithm. So we got just kind of some explanation here on the first page. A graph whose edges are given numerical values is called a weighted graph. Keeping all the vertices connected by a path resulting in a minimum total weight is called finding a minimal spanning tree. The word spanning means that each vertex remains connected to the graph. The word tree indicates that there are no cycles. Remember, a cycle is going to be where you can make a path that goes through different vertices and ends up back at the same vertex where you started. The following procedure, known as Kruskal's algorithm, can be used to find a minimal spanning tree in a weighted graph. So here's the algorithm. So it's just a series of steps. Assume that you start with a table of the weights associated with each edge, like the railroad problem in SAS 7. Step 1, put all of the weights in a list from smallest to largest. Step 2, find the smallest weight in the list and include the associated edge and 2 vertices as long as that does not create a cycle. Step 3, remove this weight from the list. Repeat steps, and then step 4, finally, repeat steps 2 and 3 until all vertices are connected. Okay, so put the weights in a list, then start drawing your vertices and edges as long as it does not create a cycle, and remove from the list, and you just keep on repeating this process. So we're going to do number 1 together here. A series of bridges will be constructed to connect a group of 7 islands. The highway department wants to make sure that a vehicle can be driven from one island to the others in this new network of bridges. The cost of building a bridge is directly proportional to the length of the bridge. The following table provides the distances in miles between each pair of islands. So the further it is, the more it's going to cost. Okay? I've got 7, so I'm going to make a little, put down 7 dots here. 1, 2, 3, 4, 5, 6, 7. So A, B, C, D, E, F, and G. All right, now I'm going to list out in order from smallest to largest all the distances here. So first I have BF is 3. That's my smallest one. I'm going to circle these so and so I've got a 4 here, that's BC, is 4. I've got 5 right here, that's CF. I've got a couple of 6s, EF is a 6, and DG is a 6. I've got a couple of 7s, AE is a 7. BG is also a 7. Got a couple of 8s. AC is an 8. AD is an 8. And actually here's another 8. FG is an 8. I've got several 9s. AG is a 9. BD is a 9. CG is a 9. And DE is a 9. I've got a couple of 10s, AF and DF. Got a couple, oh, one more. AB is a 10. Over here, a couple of 11s, CE, EG are 11s. CD is 12. And BE, the longest distance, is 13. Okay. All right, so now I'm going to start applying the shortest, starting with the shortest one, applying these bridges. So I'm going to build BF, and that's my 3 here. I'm going to do BC is 4. Now, if I did CF, that would make a cycle, and so I don't want to do CF. We're not going to use CF, but we are going to use EF. That's a 6. And I can use DG, that's a 6. AE, that's okay, and that's 7. And so at this point, I've got A, B, C, F, and E are all connected, and G and D are connected, but they're not. But those two parts are not connected to each other. So I need one more bridge, and I think this BG at 7 should do it. Now, there's a path, I believe, from any island to any other island. Okay, and even though it looks like I have a cycle here, it is not a cycle. Again, there's no way I can start at some city and end up back at that city without repeating or backtracking. And so it looks also like my total here. Notice I've got one less than the number of points, and that's always going to be kind of the way it is. The vertices, you'll have one less edge than the number of vertices. I've got 1, 2, 3, 4, 5, 6 edges, and I have 7 vertices, so that makes sense. And if I add this together, I've got 7 and 6 is 13, and 6 is 19, and 7 is 26. 26 and 7 is 33, so it looks like it's 33 miles, maybe, is that? Yeah, it's miles. So 33 miles worth of bridges is the best we can do as far as building bridges here. Okay? So, okay, let me apologize. I didn't realize until I was going back and looking at the video that you couldn't see everything I was doing here. So here's a better shot of it. I'm going to give you a couple seconds here. If you need to pause it, feel free to pause. But there is all the work for that first problem. Okay? What I want you to do is to do the same thing. Use Kruskal's algorithm to find a minimal spanning tree in this graph. Okay? And I'm going to ask you on today's practice to give me, I want you to give me the total of the minimum spanning tree. And if you could send me a picture or something of your spanning tree. Okay, draw a picture of it with the edges on there and send that to me, and also tell me the total. Okay? All right. All right, so after completing number 2 on the practice, on the assignment, what I want you to do is to take a picture of your minimal spanning tree and maybe just circle the total for your total weight, and then upload a photo of that for your assignment, and it'll have a place for you to do that. Okay? Let me remind you that tomorrow we'll start the project, and I'm adding on a day. It was going to be a 3-day project. We're going to make it 4. SAT has kind of messed things up, so we're pushing it back a day. It will be due by the end of the day Tuesday. So you'll have Thursday, Friday, Monday, and Tuesday to work on it. Should be more than enough time. I'll have the instructions for you to read tomorrow. Okay? All right. Let me know if you have any questions. Hope you're doing well. Bye-bye.